Hello, grade 11 learners. Welcome to your new normal general mathematics class. I am Teacher Ellie, and this is Telemath Aralan. For the first topic, concept of functions will be discussed. You are expected to represent real-life situations using functions, including piecewise functions. For the instruction outline, you will be learning about functions and relations and representing real-life situations using functions, including piecewise functions. The concept of relations and functions were already been discussed during your grade 8 class. Let's have a review about it. Let us start with relation. A relation is a rule that relates values from a set of values called the domain to a second set of values called the range. The elements of the domain can be imagined as input to a machine that applies a rule to these inputs to generate one or more outputs. It is a set of ordered pairs x, y. A function is a relation where each element of the domain is related to only one value in the range by some rule. The elements of the domain can be imagined as input to a machine that applies a rule so that each input corresponds to only one output. A function is a set of ordered pairs x, y such that no two ordered pairs have the same x value but different y values. Let's try to identify if the given relations are function or not. Let's start with relation f. Relation f consists of ordered pairs 1, 2, 2, 3, 3, 5, and 4, 7. Is it a function or not? Answer: it's a function. Relation f is a function because no two ordered pairs have the same x value but different y values. Next, relation g. Relation G consists of ordered pairs 1, 3, 1, 4, 2, 5, 2, 6, and 3, 7. Is it a function or not? Answer: it's not a function. Relation G is not a function because the ordered pairs 1, 3, and 1, 4 are ordered pairs with the same x value but different y values. The same also with the ordered pairs 2, 5 and 2, 6. They have the same x value. Relations and functions can be represented through mapping diagrams where the elements of the domain are mapped to the elements of the range. Given the mapping diagrams of the relations, let's try to identify which of those mapping diagrams are functions. Let us start with the mapping diagram of the relation f. Is it a function or not? Answer: it's a function. Relation f is a function because each value y in y is unique for a specific value of x. Next is the mapping diagram of the relation h. Is it a function or not? Answer: it is not a function. The mapping diagram of relation h is not a function because there is at least one element in x for which there is more than one corresponding y value. For example, x is equal to 7 corresponds to y is equal to 11 or 13. Similarly,
x is equal to 2 corresponds to both y is equal to 17 or 19. Functions as representations of real-life situations. Functions can often be used to model real situations. Identifying an appropriate functional model or formula will lead to a better understanding of various phenomena. On the succeeding examples, let us try to represent real-life situations using functions. Let us start with the first example. If you want to buy hamburgers for your friends and each hamburger costs 40 pesos, what would be the cost of X hamburgers? Let us represent or model the situation using function. Solution: let h of x be the function. H stands for the hamburgers bought. Let x be the number of hamburgers bought. Since each hamburger costs 40 pesos, then the cost function is h of x is equal to 40x. Next example. A person is earning 600 pesos per day to do a certain job. How much would be the salary of the person in n days? Again, we will represent or model the situation using function. Solution: let S of n be the function. S stands for the salary of the person. Let n be the number of days. Since a person is earning 600 pesos per day, then the total salary in n days is S of n is equal to 600n. Another example. Give a function b that can represent the amount of battery charge of a cellular phone in each hour if 12% of battery was lost every hour. Solution: let b of h be the function. Let h be the hours lost or consumed. Since every hour loses 12% of the battery, then the amount of battery function is b of h is equal to 100 minus 0.12h. Some situations can only be described by more than one formula, depending on the value of the independent variable. These situations can be represented by piecewise functions. Let's examine the following examples. Let's have the first example. A user is charged 300 monthly for a particular mobile plan, which includes 100 free text messages. Messages in excess of 100 are charged 1 peso each. Represent the monthly cost for text messaging using the function T of m, where m is the number of messages spent in a month. The situation of the problem has two scenarios. First, you will only pay 300 pesos if you have consumed your 100 free text messages. Any excess of messages being sent is charged with 1 peso each. The cost of text messaging can be expressed by the piecewise function T of m is equal to 300 if m is greater than 0 and less than or equal to 100, and 300 plus m if m is greater than 100. Next example. A certain chocolate bar costs 50 pesos per piece. However, if you buy more than 5 pieces, they will mark down to a price of 48 pesos per piece. Use a piecewise function to represent the cost in terms of the number of chocolate bars bought. The scenario has two situations. If you buy 5 chocolate bars or below 5, you will pay 50 pesos each. But if you buy more than 5 pieces, you will pay 48 pesos each. The input value is the number of chocolate bars bought, and the output is the cost of the chocolate bars bought. If f of n represents the cost in terms of the number of chocolate bars bought, the function can be represented as follows. F of n is equal to 50n if n is greater than 0 and less than or equal to 5, and 48n if n is greater than 5. DIY, do it yourself. Try to answer the following exercises. Let x represents the regular price of a book. Give the function g that represents the price of the book if a 10% discount applies. You are going to find the function g. What is your answer? Let us see if your answer is correct. Solution. Let g of x be the function. Let x represents the regular price of a book. Let 0.10x represents the discount. Therefore, the function that represents the price of a book with 10% discount is g of x is equal to x minus 0.10x. A jeepney ride cost 8 pesos for the first 4 kilometers, and each additional integer kilometer adds 1.50 pesos to the fare. Use a piecewise function to represent the jeepney fare in terms of the distance d in kilometers. Try to find the piecewise function. What's your answer? Is your answer correct? Let us see. If f of d represents the fare function of distance, the function can be represented as f of d is equal to 8 if d is greater than 0 but less than or equal to 4, and 8 plus 1.5d if d is greater than 4. 100 meters of fencing is available to enclose a rectangular area next to a river. See the figure. Give a function a that can represent the area that can be enclosed in terms of x. Try to find the function. What's your answer? Let us see if your answer is correct. The area of the rectangular enclosure is A is equal to xy. Since only 100 meters of fencing is available, then x plus 2y is equal to 100, or y is equal to 100x over 2, simplify, is equal to 50 minus 0.5x. That is our value of y. Substituting to the original area, a of x is equal to x times 50 minus 0.5x. Therefore, our function is a of x is equal to 50x minus 0.5x squared.
That's it! I hope what you have learned today made your day productive. I also pray that this COVID-19 will not hinder your continuous learning. Again, I am Teacher Ellie, and this is Telemath Aralan.